Welcome to Lesson 2 Continued on Proportions. In this video, we'll look at some proportional diagrams. Now, in order for a reduction or enlargement to occur, all sides need to be proportional, meaning the ratio of corresponding sides are all the same. So if you have a triangle, for example, and you want to create a proportional diagram, you can't just increase or decrease one side length. You need to increase or decrease all three side lengths by the same amount. In example 1, we're given some rectangles, and we have to determine which of the rectangles, A, B, C, or D, are reductions or enlargements of the original using the chart below. Now in this chart, we're going to start by comparing figure A to the original by determining the ratio of two corresponding sides to see if they are the same. So we'll start by using our ruler to measure the side lengths in the original diagram. So now placing my ruler along the top edge, I get a measurement of 2.5 centimeters. And down the side, I get 1.5 centimeters. Now for figure A, I get 1 centimeter by 0.5 centimeters. Now going back to the chart and writing that as a ratio, I'll start with 0.5 centimeters, and I'll divide that by the corresponding side length in the original diagram, which is 1.5 centimeters. Now dividing that, I get a value of 0.3 repeating. Now if I pick the other two corresponding sides, I get 1 centimeter divided by 2.5 centimeters, which works out to be 0.4. So since the scale factors are different, it's not proportional. So is there a reduction or enlargement here? We can say no, since not all sides are proportional. Now for diagram B, we'll once again measure the side lengths. Here I get 2 centimeters, and down the side I get 1.2. So setting that up as a ratio again, I get 1.2 centimeters corresponding with 1.5 centimeters. Dividing that gives me 0.8. Taking the other two corresponding sides, I get 2 centimeters divided by 2.5 centimeters, which is also 0.8. So here we do have a proportional diagram. So is there a reduction or enlargement? Yes, there is. We can say all sides were decreased using a scale factor of 0.8. So that means that figure B is a reduction of the original. Okay, for figure C, measuring the top, I get 3.7 centimeters, and down the side, I get 2.5 centimeters. So setting those ratios up, I get 2.5 over 1.5, which gives me 1.7 repeating. Then 3.7 over 2.5 gives me a different number. I get 1.48. So there is no reduction or enlargement here, for the same reason as above, since not all of the sides are proportional. Now for D, got 5 centimeters by 3 centimeters. So if I take 3 centimeters and divide that by the corresponding side of 1.5 centimeters, I get a nice value of 2. And then taking 5 and dividing that by 2.5, I also get 2. So here we have another proportional diagram. And in fact, it is an enlargement because the scale factor is bigger than 1. So I'm going to say that all sides were increased using a scale factor of 2, so that means D is an enlargement of the original.